Welcome back to my channel and a happy Saturday to everyone. So guys, in this video I'm going to explain what is a packet and how it works. Alright, and so in the previous video I had explained how an OSI model, open systems interconnect in networking, works. Along with each layers, I explained what was the role of each layer within the OSI model. So in this video I'm going to explain what is a packet, and how it works exactly in computer networking. And you can ask me, guys, like, what is a packet exactly? Okay, so in internet, right, internet world, everything involves packets. For example, let's say a web page, right, that you receive um, on the browser comes as a series of packets to you. Okay, and every email that you send, right, it leaves a series of packets to the destination email address that you email. All right, and networks, right, that ships information around in small packets, right, are called as packet switched networks. So this is the terminology. And whatever amount of data that you send, right, let's say if you're sending or uploading 10 GB of data on Google Drive, and that happens via packet segmentation. Basically, small amount of packets get segmented, or are broken into several packets in small pieces, and then that's how it gets transported and carried away to the destination. So these are all the small packets. Okay, so that typically contains somewhere around 1000 or 1500 bytes. So each small packets, which is typical in size, it ranges around 1000, between 1000 and 1500 bytes. Okay, and you may ask me another question, like, why is data divided into packets? Okay, so data is basically divided into packets because it makes the network that you work upon more efficient. Okay, and it also allows the network to balance the load. Okay, so the load balancing happens across various pieces of equipment involved within the network that you are working, and the destination network that you are interacting with. And this happens on a millisecond by millisecond per basis. Let's say, for example, let's say if there is a problem detected within that particular or within a piece of equipment within that network. Okay, whilst a message is being sent, so when there is a lot of packets in transit, we can analyze that particular packet that is getting dropped. Okay, and that particular problematic packet can be routed to, routed to error checks. Okay, that particular packet with the problem can be error checked and analyzed and then rectified, and to ensure the delivery of the entire message. Okay, so the error checks, right, for a particular problematic packet, which is commonly called as cyclic redundancy check. Okay, so this check involves thorough inspection of all the packets that are being transmitted to the destination address. Okay, and this ensures a clean and safe transfer of the data that is encrypted and encapsulated within a packet. Okay, it's just like your lace, right, lace which comes airtight, and frito lace chips, potato chips that you buy, right, it is having completely, it gets packed within a packet. Okay, packet cover, and it's completely airtight to ensure that it does not gets rotten. Okay, similarly, the data within the network is actually packed within a packet. Okay, and one more important thing is, so everything that you do on the internet, right, that uses packet switching. Okay, and your internet itself is a connectionless network. And I'm just going to explain you by just opening up something on Google. Structure of packet, right? There are three structures of a packet. One is a header, and then there is second comes the payload, and third comes the trailer or footer. Okay, which I'm going to explain just now to you. Structure of a packet. Just going to type it on front of you. Okay, you can see here a network packet has three parts. The first being the header, the packet header, and then the payload, which contains the actual content, the message, and the last, the trailer or footer. Okay, and I'm going to explain each of these parts in more detailed way. Okay, so let's begin. Let me just show you, open up a Google image in front of you and explain. All right, so this is the best image that I can explain in more depth on what these each parts are. Okay, I just want the image for you. Okay, all right, so let me keep my screen to this particular portion where it gives you the idea of what header contains, what payload contains, and what trailer contains. But I'm just going to give you a more in-depth explanation. Okay, so basically the header, right, the header contains the instructions mainly about what the data is uh, going to be carried away by a packet or by the packet. So these instructions, right, the header contains are like length of a packet. Okay, so some networks, right, have fixed length packets. Okay, while others rely on the header to contain this information. And as you can see here, it contains the sender's IP address, okay, the client, and the receiver's IP address. Receiver's IP address is nothing but the destination address, right, and the protocol and the packet number. All right, so I'm just going to explain that protocol part. Protocol is nothing but uh, each of the message or data that you're going to send is of different types. For example, let's say you are trying to upload something on a web page, so that becomes a HTTP protocol that you are trying to send the data through. Okay, and if you're sending an attachment via email, all right, that becomes a SFTP protocol. Okay, simple file transfer protocol, which is usually used on emails. Okay, on email softwares. And let's say you are trying to share or upload some file on FTP sites. What does it what does the protocol define? It's FTP protocol, file transfer protocol. All right, so these are the protocol assignment that, I mean, not an assignment, I would say, but a defined or a fixed information that is available on the header section of the packet. Okay, protocol is already assigned in that. Okay, those information is stored within the header of the packet. Okay, and which is usually between 96 bits of size. Okay, size or length you can call. And then comes the payload. Payload is generally the actual message or the data that is going to be transferred to the destination address. That is usually between 896 bits of length. All right, so the final part is the trailer part or footer part. Okay, that does the error correction, as well as it advises the receiving device that it has almost got to the end of the actual packet. So like I said previously, the error correction happens. Okay, so it also, for example, let's say there are 100 packets. So you have actually named it as 1 2 3 4 5 6 7 8 9. Okay, this particular part that ensures the sequencing of the packets, right, it's traveling like a train, the compartment, right, 1 2 3 4 5 6 until 10 or until 100. So it ensures that there is no so it ensures that the ordering of the packets is in the right order, right sequence. Okay, there is no interchanging between the packets okay, and that's when it's called as error correction, okay. And also it takes care of any issues within the entire packet, okay. Like for example, let's say when I say that within a chips packet, right, if I take a real life example, um, the quality checks that happens, right, post the packet is completely sealed, and there is a UGMARK certification that is put on that chips packet, sealed on the chips packet, and after that it actually goes to quality checks also, right. The quality check team ensures that the chips are safe for the consumers to eat. All these checks happens, right, through the quality food quality control team. So that is the responsibility of this trailer part, the third part, which does the error correction and ensures there is no issues with the data packets, as well as the sequencing of the packets is not affected. And this ensures the safe and efficient uh, way to send the entire message of the data to the senders, or I mean to the destination receiver's IP address, the destination address from sender's IP address. So guys, this is, I understand this is quite a bit of theoretical part, okay. These are the stuffs that can't be shown practically, okay. However, I can show you all these things in Wireshark tutorial as a basics, I mean in a very basic manner, but very much advanced stuffs is something that has, I mean, as a, I mean as a home based user, I'm actually restricted to show all these things in a more practical manner. Like if I had an organization, or if I have a company that has all these networking equipments, I can show you this in a more practical sense. But however, this is a kind of a theory which I think you must read and understand it, okay. So practically showing all these things, all these stuffs is a bit difficult or challenging, I would say, rather. Okay, let me try giving you an example, or maybe real life example that comes off my head, okay, for this trailer part, how it does it practically, okay. When I say error correction, okay, so basically what happens is, let's say um, I mean, let's say we are sending an email just now, okay, and the message might get broken into lot of small packets, okay. And then what happens is, and you're just sending an email to your friend, okay. The email, let's say, is about 3500 bits, which is equivalent to 3.5 kilobits, okay, in size. And the network you are sending it to uses a fixed length packets, meaning 1 kilobit of length, or 1 kilobit of the transmission size of the packet, which is 1024 bits, okay. And the header of your each packet is 96 bits long, as I'm showing here, okay. And the trailer is 32 bits, which is designated, leaving 896 bits of your actual message, which is the payload. And to break the 3500, so to break the 3500 bits of message into packets, you will need 4 packets, okay. So a mathematical calculation would be to divide 3500 by 896 bits, okay. So the 3 packets will contain 896 bits of payload, and the 4th packet will have 812 bits of data. So here is what one of the So here is what one of the 4 packets would contain, guys, okay. So each packet's header will contain the proper protocol assignment, like the originating address, I mean the IP address of your computer, the source computer, and the destination address, the IP address of the computer where you are sending your email, that is the receiver's email address, Okay, and then the packet number 1234, since there are 4 packets, like I said, the numbering of the packets happens. Okay, and so what routers, right, routers in the destination address or the destination network, what it will do is will look at the destination address that contains in the header, the destination in the sense the header, right, receiver or the destination IP address. Okay, so the destination address in the header, and router will start comparing it to their local lookup table, okay, which is called as routing table, to find out where to send the packet. Okay, so these are again networking concept, guys. If you know routing table, you need to actually, like, if you know, if you have completed CCNA certification, this is you'd be able to understand all these concepts very easily. But if you are rookie to networking, okay, it's this video is going to be little bit of challenging for you to understand or grasp. So at the end, what happens is the router tries to compare the destination address, right, within its lookup table to find out where to send the packet. Okay, and then what happens is once the packet arrives at the destination, that is your friend's computer, your friend's computer will strip the header and trailer of each packet and then reassemble the email, okay, based on the numbered sequence of the packets, which I said already, right? There are let's imagine I told you 1 2 3, and there are 100 of packets, and it's ordered 1 2 3 4 200 in the number, okay, in the ascending order, you can say, okay, or descending order. I'm bad at maths, guys, okay. So I think 1 to 100 will be ascending order, or 100 to 1 will be descending order. Sorry guys if it's wrong. Okay, so it's basically the sequencing or ordering of the packets, okay, that are numbered actually. So at the end, again I will repeat, what happens is your friend's computer will strip off the header and trailer file, or the trailer section, and just start reassembling the email based on the sequence of the packets. Okay, and then the actual message is delivered to the receiver's machine or receiver's IP address. So this is what happens in the trailer section, okay, which I gave you on a real life example, by giving you a real life scenario. Okay, and so this is the in-depth explanation of what the packet is and how it works within the computer networking, and particularly in the OSI layer of the OSI model, okay, within the computer networks. And if you found this video helpful, please hit the F4 button and do not forget to subscribe my channel. We will meet in the next video, where I will be showing you the basics of Wireshark, on how to use Wireshark, and particularly that will be a basics tutorial, okay, for you to understand and gain more knowledge on it. Okay, so I'm just going to instigate the interest of instigate interest within yourself to do more research on Wireshark and learn it in depth. Okay, thank you so much.